Alright, for this lesson we're going to be talking about waves, and it is in, now it's in AS Physics. It's in year 10, P4, and triple year 10, P5. Alright. Okay, here we go. Now let's just draw a few waves. Let's just say that's 1 second. And then let's just say that's 1 second. All right, so let's talk about amplitude. Let's talk about frequency. Let's talk about wavelength. Let's talk about amplitude, period. Let's label this A. This is A, wave A. That's wave A. And this is wave B. Let's just say that this is 2. So every 1.5, that's about here, so that's 4. We're just going to estimate. So every 1.5 is 2. That's 2. That's 4. That is 6. All right, so now let's just say that on the y-axis is volts. On the y-axis, so this is voltage. On the y-axis here is also voltage. On the x-axis you've got time. So time on the x-axis, time, and this is 1 second. Right, so let's just do a rough estimate. So the amplitude for wave A, the answer is, let's just say 6 volts. So for A, it is 6 volts. So what's the definition of amplitude? Amplitude is the height of the wave from the middle to the top of the wave. So the top is the crest, the bottom is the trough, the middle, where it's equal to 0, that's called the equilibrium position. Equilibrium position. And the symbol for amplitude is A, so that's A. So 6 volts is equal to A. So okay, so set A is equal to 6 volts. For wave B, what's amplitude? Now it's more than 6. What is it going to be? Is it 6? Is it 7? Shall we say it's about 7? I'm just going to say about 7. So that is approximately equal to 7 volts. Frequency is measured in hertz. Hz, or in full is HERTZ, but you shorten it with a capital H and a small z, hertz. Now frequency is how many waves per second. Let's write down here. frequency is waves per second. Waves per second. So frequency is waves per second. Amplitude is distance from equilibrium position to either the top or the bottom of the wave. All right. So the frequency is how many waves there are per second. The amplitude is the distance from the equilibrium positions to the top, to the crest, or to the bottom. That is the trough. Why did I put a T there? To the trough. All right. So frequency. So how many waves are there in this case? So there is one wave. This is half. Let's just say that is about. Let's just say it's 3 point. Right. So that's 1.5. So it's more than 1.5. Let's just say it's 1.6. So the frequency for A is about 1.6 hertz. 1.6 hertz. What about for wave B? So for wave B, how many waves are there per second? So remember, this is 1 second. So there's 1, 2, 3. So it's more than 3. So it's 3 point something. 3 point. Well, this is a half. This is a quarter. So an eighth. An eighth is 0.125, isn't it? All right, so let's just say 1, 2, let's just say 3.1. It's about 3.1 hertz. Okay, so here you have 1.5, and here you have, oh, that's more than 6. Hold on. Well, there's about here, isn't it? And that's about 2.5. So shall we say that's 1.8? So it's about 1.8 hertz. All right. Now, what's the wavelength? Let's use a ruler. Now, the wavelength is the distance from successive points on the wave. So what I mean is that the one wavelength will be from there to there. So at this point, this was doing the same thing when it was at this point. Imagine it's going this way. So this is doing the same action as it was doing here. So that would be one oscillation, one wave. Or it could be from crest to crest. So from this crest to this crest. So the wavelength will be from there to there. Well, let's just see how accurate my drawing is. So from there to there is 14 centimeters. From there to there, it's about 14 centimeters. Right, so the wavelength is 14 centimeters. The wavelength, right, the symbol for wavelength is, okay, so yes, the wavelength is that symbol there. Wavelength is 14 centimeters. Let's try this one. The wavelength is from there to there. So let's just say 8 centimeters. Right, this one's not very good. All right, so right, well, let's just say it's 8 centimeters for now. For B, the wavelength is 8 centimeters. Oh, 8 centimeters. So that's 8 centimeters. Now, the period is how many seconds does it take for one wave? So one wave, well, obviously it's going to be less than 1 second because 1 second is here. So for one wave is less than 1 second. Now the equation for period is T is equal to 1 over F. So the period is equal to 1 over the frequency, that's period, and that is frequency. So if we get a calculator out, we've got the frequency A. So if we do 1 divided by 1.8, we get 0.5 recurring. So for A, it is equal to 0.556, let's just say, to 3 decimal places. And then for B, it is 1 over 3.1. So 1 divided by 3.1, and that gives you 0.322 or 0.323. 0.323 seconds. The units is seconds. All right, so let's just recap. So the amplitude is the distance from the equilibrium position where it's there to here. Assuming it's symmetrical, it's the same from there to there. So if we look at the y-axis, that is 6 volts. This is more than 6. So the amplitude for A is 6 volts. The amplitude for B is, I just made it up, so that is probably 7 volts, roughly 7 volts. Frequency is how many waves there are per second. How many waves there are per second. So in 1 second, how many waves are there per second? So here there's 1 wave. Here's half of the wave, and it's more than 1.5. Oh, hold on. Why? That should be 7. Should I make that 7? Oh, that should be 7. Hold on. Yeah, that should be about 7. Let's say that's 7. So therefore that is 1 divided by 0.59. Let's just say 0.59. This is all rough anyway. I mean, if you did it on the graph paper, you should be able to work it out. This is not on graph paper. Okay, so roughly, there are 1.7 waves per second. So that's one. So it's roughly 1.7 waves per second. For B, there are about 3.1. So that's 1, 2, 3, and there's extra bit there. So it's 3.1. Wavelength. I used the ruler to work out the wavelength. So it's from there to there, or from there to there. So that is 14 centimeters. Now, should we leave it like this? The proper unit is not centimeters, it's meters. So you can say 0.14 meters, and here will be 0.08 meters. And the period is how many seconds it takes for one wave, and we use that formula. We use that formula for this.